Welcome to the DIY Honda Garage channel. In this presentation, we will address DTC P0191, which indicates that the fuel rail pressure sensor is out of range in the Honda Civic models from 2016 to 2021. The fuel rail pressure sensor plays a crucial role in measuring the pressure of the fuel within the fuel rail. Located near the fuel injectors, it informs the powertrain control module, PCM, about fuel delivery conditions, which is critical for optimal engine performance. A malfunction in this component can lead to various issues, including poor engine performance and reduced fuel efficiency. Understanding the symptomology, as well as performing precise troubleshooting steps, is vital for rectifying this concern. We will outline the detailed troubleshooting steps and tips to ensure proper diagnosis and repair of DTC P0191. DTC P0191 refers to the fuel rail pressure sensor being out of range, which can significantly affect the functioning of the vehicle. This sensor, located on the fuel rail near the fuel injectors, monitors the fuel pressure to ensure sufficient fuel delivery for effective engine combustion. The data it provides is crucial for the PCM, which utilizes this information to adjust fuel injection timing and volume. When the sensor fails, or if the pressure reading exceeds the threshold, problems arise, leading to potential engine performance issues. It's important to ensure that all electrical connections to this sensor are secure, and to verify that the sensor itself is functioning within the designated parameters to rule out any performance issues stemming from this part. The causes of DTC P0191 can be divided into several key areas. First, a faulty fuel rail pressure sensor is a primary suspect. If this component malfunctions or is out of calibration, it will fail to report the correct fuel pressure. Next, wiring issues, including shorts or breaks in the wiring harness, can cause intermittent signals or incorrect voltage to reach the sensor, ultimately signaling an error to the PCM. Additionally, problems in connectors, whether from corrosion or loose connections, can lead to the same issues. It's crucial to thoroughly check all related wiring and connections before concluding that the sensor itself is defective. Symptoms associated with DTC P0191 can manifest in various ways. Drivers may experience poor engine performance, as inadequate fuel pressure can prevent optimal combustion, leading to loss of power. Additionally, warning lights on the dashboard may illuminate, alerting the driver to a potential engine fault that needs attention. Furthermore, a noticeable drop in fuel efficiency may occur as the engine struggles to receive the required fuel for normal operation. These symptoms can lead to reduced driving comfort and potential long-term damage if not addressed promptly. Hence, understanding these symptoms is essential for timely repair actions. The first step in troubleshooting DTC P0191 involves verifying the problem. Begin by turning the vehicle to the on mode without starting the engine, allowing various systems to initialize. Next, clear the DTC using the Honda Diagnostics System, HDS interface. This step is crucial as it resets any stored error codes that may be affecting current diagnostics. After clearing the code, wait for at least 10 seconds. This gives the vehicle time to reset its systems, enabling the technician to check for new pending or confirmed DTCs. If DTC P0191 appears again during this check, it indicates a recurring issue that needs focused attention. In the second step, the goal is to identify the potential failure area. Start by turning the vehicle to the off/lock mode to ensure that the system is inactive and safe for testing. Disconnect the fuel rail pressure sensor's 3P connector. This is critical to isolate the sensor from the system. With the connector disconnected, turn the vehicle back to the on mode. Now you will need to measure the voltage between specific test points on the disconnected connector. This measurement is key as it provides insight into whether the issue lies with the sensor itself, its wiring, or the PCM. Check for approximately 5.0 volts at the designated points. A consistent reading signals that the wiring is intact. Step 3 involves confirming if there are any shorted wires in the system. Turn the vehicle back to the off lock mode and jump the SCS line with the HDS. This essentially puts the vehicle into a diagnostic mode. Wait for more than 1 minute for stabilization. After this, disconnect the PCM connector E, ADP, to isolate the vehicle's control unit. You will then check for continuity between the test points on the fuel rail pressure sensor connector and the body ground. If there is continuity, it indicates that a short exists in the VCC1 wire between the PCM and the fuel rail pressure sensor. If no continuity is found, proceed to the next step to check for open wiring conditions. For step 4, the focus shifts to checking for open wires. Repeat the continuity test between the fuel rail pressure sensors, connectors, and the PCM connector E, ADP. Make sure both connectors are disconnected and that the vehicle is in the off lock mode. If continuity is present, this indicates that the wire is intact and functioning correctly. Thus, you can move on to the next troubleshooting step. However, if there is no continuity, it indicates an open circuit in the VCC1 wire between the PCM and the fuel rail pressure sensor. This requires immediate attention to repair any faults in the wiring or connections. During step 5, the focus is on checking continuity in the SG1 line. As with previous tests, ensure the vehicle is in the off lock mode and that both connectors are disconnected for safety and accuracy. Measure continuity between test points on the fuel rail pressure sensor connector and the corresponding PCM connector. If there is continuity, it affirms that the SG1 wire is functional and not contributing to the DTC issue, allowing you to proceed with additional checks. If there is no continuity, it indicates there could be an open circuit in the SG1 wire, necessitating repair. Identifying any damage to wires or connectors can often resolve persistent issues related to faulty sensors. Step 6 guides you through checking for shorted wires in the PF line. As always, start with the vehicle in the off lock mode. By jumping the SCS line again with the HDS, you confirm the vehicle is in diagnostic mode. Once more, disconnect the PCM connector E, ADP, to isolate it from the system. You will be testing continuity between the PF wire of the fuel rail pressure sensor and the body ground. If continuity exists, it indicates that there's a short in the PF wire, prompting necessary repairs. If continuity is not found, proceed to the next step, which focuses on checking for open circuits in this wire. In troubleshooting step 7, the task remains to check for open circuits in the PF line. With the vehicle still in the off lock mode and both connectors disconnected, measure continuity between the designated terminals of the fuel rail pressure sensor and the PCM. If continuity is confirmed, it indicates that the PF wire is intact and functional. Should continuity fail, it confirms that there's an open in the PF wire between the PCM and the fuel rail pressure sensor, necessitating repairs. Correcting any breaks in the wire is essential for ensuring that the fuel rail pressure sensor can communicate effectively with the PCM, preventing further DTC occurrences. The final troubleshooting step involves testing the fuel rail pressure sensor itself. Begin by substituting a known good fuel rail pressure sensor to confirm its functionality. After replacement, ensure to reconnect all connectors securely, as a loose connection can also cause errors to persist. Next, exit SCS mode using the HDS and turn the vehicle to the on mode. Clear the DTC with the HDS once again. Following the clearing procedure, wait for at least 10 seconds to allow the systems to reset and assess for any pending or confirmed DTCs. If DTC P0191 reappears, it indicates a refractor issue, potentially with the PCM. If it does not appear, the replacement sensor has resolved the issue. Upon completing the troubleshooting and repair process for DTC P0191, final verification is imperative. Ensure to check for any remaining diagnostic trouble codes, DTCs, in the system. After clearing the codes and confirming the absence of errors, perform a test drive under various conditions to assess the vehicle's performance. Monitor any changes that might indicate underlying issues that were not addressed. It's crucial to confirm that the fuel rail pressure sensor is now responding correctly and that its data is effectively communicated to the PCM. A successful verification process will ensure that the issue is resolved and prevent future occurrences of DTC P0191. In order to prevent the recurrence of DTC P0191 and maintain optimal vehicle performance, regular preventive maintenance is essential. One crucial aspect is conducting routine inspections of electrical connectors and wiring associated with the fuel system. Ensure that all connections are clean, secure, and free from corrosion. Additionally, monitoring the overall health of the fuel system will help identify potential issues before they escalate into more significant problems. Adhering to a timely service schedule, including fuel filter replacements and fuel system cleaning, can also enhance the lifespan of the fuel rail pressure sensor and other related components. Keeping meticulous records of maintenance can aid in tracking any persistent issues. In conclusion, DTC P0191 is a critical error that indicates issues with the fuel rail pressure sensor, which can adversely impact engine performance. We re-emphasize the importance of thorough troubleshooting to accurately pinpoint the underlying cause of this DTC. Each step in the troubleshooting guide is designed to guide technicians through a structured approach to identify and repair the issue effectively. Additionally, we highlighted the role of preventive maintenance in keeping the fuel system healthy to prevent this trouble code from recurring. By employing proper repair techniques and regular inspections, vehicle health can be significantly enhanced, ensuring a smoother driving experience. Please like and subscribe to the channel. See you next time.